Okay, so anyway, for today's workshop, it's called Scientific Software Basics. And in this, you should basically learn how to use the Unix or Linux command line and how you can interact on the command line on resources like Mana, or if you have your own Linux box or whatever. And if you're running on Windows or Mac, the Mac has a similar shell. If recent versions of Mac have the Z shell, not Bash, but it shares some similarities. And then after I'm finished, my partner here, Mozetti, will talk about the command line Git, GitHub, and for version control, and GitHub pages to share your science. So everyone here should have an account on Mana. You should have UHDuo MFA enabled and be able to connect. Obviously, you're all connected to the workshop, but we're going to get on to Open On Demand with a web browser. And so that way, everyone in the workshop will have the same environment. We won't be dealing with Macs and Linux and Windows boxes. So let's go through the setup and let's get started. So again, it's the same prerequisites here. So what we'd like to do is just, you can right click on this link here that is Mana, and in Chrome, so basically you need Chrome OS, Firefox, or Safari. I haven't tested out Firefox and Safari, but in Chrome, you can right click, and if you're not on your own machine, most of you are probably on your own machine, so it doesn't matter so much, but if you're on a public machine, you would want to open up the Open On Demand to Mana through a through an incognito window. So, but I will go ahead and I'll just open a link in a new tab. And then you see I'm going to get this. And I'm going to go ahead and type my name, password. And so basically, everyone should be getting the gold screen. And I don't know, since this is the first run through, I don't know how we're going to do feedback, if somebody's going to monitor chat, but you should go ahead and type your password. And I failed, of course. So let's do this. Okay, so basically, it's not going to let me. There we go. Okay, so I finally typed my password correctly. It's been a long week. So most people would have a choice of ways that they would authenticate. So I'll send a push to my phone. Most of you are probably familiar with this. And then grab my phone, verify my identity, and I'm in. So basically you should see the same Mana screen. Some Slack. Oops. Okay, so is go down here. So everyone should be authenticated and seeing this screen and set up.
Let's do this.
Everyone gotten to that point? Okay. Put people in gallery mode and big. Okay, so assuming everyone got to here, then we'll go on down, and what we want to do is we want to launch an interactive session on a compute node. So for the workshops, David was kind enough yesterday to set up a special partition that we'll be using today and probably for the workshops going forward. The stuff today is not that computationally intensive, but perhaps some of the future ones will be. And so it's useful to not put all that load on the login node. So basically from here, you would mouse over interactive apps, hit desktop, and then you should pop up this item here, and then we'll go through and do that, hit desktop, and it pops it up. And what we want at this point, assuming we're already at 3:15, and that we probably want to endeavor to end on time, that 2 hours should be sufficient. If you think you want to stay and work through more of the examples, since we probably won't even cover all of the things that are actually listed or published on the workshop, you could put in more hours if you thought you wanted to spend more time. You should have put in one core. You only need one core, 6 gigabytes of RAM, and you don't need any GPUs. And you can either get email or not. You could uncheck it if you want. And then you're just going to go ahead and launch. And basically, this is the slide here that you can be looking at on your own web browser, since if you're following in the setup section. And hopefully, okay. So I guess I failed to follow my own advice, and I believe I didn't actually launch into I didn't follow this, and I'm not sure if I launched into workshop or if there's a problem. Let's see. So I'm deleting some old stuff I did yesterday. But basically you should be getting something like this, and it's queued. So are people getting onto that partition, the workshop partition? Okay, so I was just being impatient. And as you can see from the setup, the next one down is I was waiting, but I was impatient. It says, please be patient, but I wasn't reading. So, and then that screen turned from this blue bar and my job ID, and now I have a job, and here it is. And so what we're going to do today is we're going to, if you just click on this link here, that will actually get you a shell. And so that's the shell that a good part of today's workshop will take place in. So, and I'll go back over here to let you know that your compute node has been assigned once you see that. And then when you launch it, many of you may not have run on the nodes in this partition. And if you haven't, you're going to see something like this, the authenticity of the host, blah, 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 GPU, and ask you if you want to continue to connect. And you will need to say yes if you want to continue on. So when you answer yes, it turns out that just by virtue of the way it works, you'll get kicked out. Now, I believe I've been on both nodes. I'm pretty sure I've been on this one. So I'm going to get this screen here where I'm actually logged in, and I can show you that I'm in my home directory and I'm on GPU 0016. So other people will get kicked out, and then they'll have to go back to this interactive browser session and click the link again to get a new shell. And you could go ahead and close. You should have, when you click it a second time, it'll open up another browser tab. So is everyone following along pretty much?
It's funny, my screen says my last login was Saturday, October 30th, which is tomorrow.
Yeah.
It says, okay.
The cluster is in, Mana is in UTC. So Mana's in Greenwich, England, I guess.
Okay, that makes sense.
Yeah. So yeah, that's something to be aware of. It's, I guess you could say there are historical reasons for that, but they may be better than historical reasons that don't come to mind right now. So then the other thing you may notice about my screen is it's not like my screenshots here. My screen is white. And if you go up to the themes here, you have choices. The default is a dark screen. And for those that don't like dark mode or want to choose something else, at any time during the workshop, if you want to see some different crazy themes, you can go ahead and change your outlook. Okay, so that's pretty much it for that. Does everyone have a shell? Okay, I see one thumbs up. Okay, more thumbs up. That's 3. Another one. Some Slack. Okay, so the next thing we're going to do is, even though we're going to do a shell workshop, we're going to do something in the shell to begin with. But part of it is just in the browser. The last thing on this first screen says download datashell.zip to your home directory. And so if you just go ahead and highlight that, you should be able to cut it and just paste it and hit return. And then you should see this, and you're downloading the zip file. And then the next thing is on the slide says unzip. So assuming you haven't moved around or anything, you could do a ls data shell zip and see that it's there. But basically, you just need to say unzip and then data shell zip, and you'll unzip it, and then we can, I guess, proceed on to the next thing if everyone's set up with in their home directory, having unzipped the files that we'll be using.
Can we go through the zip again? Sorry, I copied the .zip that you mentioned in the repository, but
actually, can we go one step back? I'm sorry, mine just for some reason, I just was able to connect. It said yes. Are you sure you want to continue connecting? And I typed in yes. So now I have my login name at GPU 0016. So where do we do from there?
Right.
So sorry.
So basically, you got here, you said yes.
Yep. I'm right after that.
And then were you kicked out?
No. It says, I mean, I'm logged into at a GPU node.
So you have something that looks like this one
Yep.
here.
Exactly. Yeah.
Okay, so I'm not sure. I have this part in getting kicked out because that's what happened to me yesterday. So
Oh.
I have that only as a, I think I did it to both. Well, I know it happened to me once, but I'm not sure if everyone has experienced this or not. This is,
No, it just kept me right. It just logged me in directly to a GPU node.
okay, what browser are you on?
Safari.
Okay, so I'm on Chrome and I guess that's a browser difference.
Okay.
I'm sure deep in the open on demand code, there's something that is treating those two things differently.
I'm okay though, right? I want to be logged into the node, right?
Yeah,
Okay.
exactly. So,
So what do we do from here?
okay, so from there, all you would want to do is to grab this.
Oh, I see.
Just grab those two guys and
That's in your,
issue them while you're still in your home directory.
sorry, that file that you're looking at, that's in your GitHub IO.
Yeah.
Oh, navigating files and directory. I see. Okay.
Yeah, so you're issuing the command wget, which is going from the login node, like rather from the GPU node that you're on, going out basically out of the cluster, out to the GitHub and grabbing that file. So all of the compute nodes on the cluster can get out to the web, so you can download.
So, but sorry, I think I'm a little lost in terms of the document that you have pulled up here. Where can I'm at the CI tracks github.io. I'm just looking to see
Okay,
where
so
I could
this
copy
is setup. So if it's the first thing before the introduction. Normally setup is
oh, I see. Got
in
it.
this
Perfect.
thing
Okay.
involves 3 different operating systems and whatever. So from the GitHub IO, you hit setup.
Sorry, I went down the rabbit hole. I was like peeking ahead, so I was lost. Okay, I got it. Thank you.
Okay.
So wget, and then that wget that you want us to copy in, is that in the setup here?
Yeah, and I put it in chat to everyone. So
Oh,
if you want to, if you're already logged in and everything, we can
oh, I see. I got it. Okay.
go
Perfect.
ahead and do that. And then it's just going to be an unzip. And then I thought we would, to navigate back on this page, you have to go up to the top here and hit home. It's
I got it. I'm with you now. Okay.
okay. So
Thank you.
everyone is caught up. Okay. I was thinking, especially in the consideration of time, I don't know, Maria, can you do a quick poll just to see if people are more interested in the shell part or the Git part? Would that be possible? Anyway, okay, we're not, I guess we could do that in time. So we'll go ahead and we'll get into introducing the shell. So what is a command shell and why would you want to use one? Basically, if you want to use Mana, many people would not be able to just use Jupyter Hub or RStudio. We do have people, at least 1 or 2, that use just RStudio. They don't know the command line. They love the fact that they have plenty of resources and have great facility with RStudio, and so they just come in and do that. But many people need, their applications are not amenable to just running in Jupyter Hub or RStudio. So the objective is to explain how the shell relates to the keyboard, the screen, the operating system, and users' programs. So explain why and when command line interfaces should be used instead of graphical user interfaces. So if you have, so at this point, of course, most people are interacting with some kind of graphical user interface. Probably most day in, day out, you're looking at your phone and most operating systems you're running on, including on Open On Demand. There's a lot of graphical stuff there, but more or less, the shell has some advantages in that those things that aren't yet hooked up to GUIs, and if you know the commands, you can sort of automate things. If you're a programmer and you know Python or virtually any other program, most programs have hooks into the operating system on Linux. So for instance, Mosetti said, oh, he hadn't really looked at the shell in a while because has such facility with Python that he can do these same kinds of things in Python. So it's there's probably a little less of a learning curve to learn some shell commands, and in some instances you may need to know at least a little bit. So here we are. So the shell is a program where users can type commands. The shell is possible to invoke complicated programs like climate modeling software or simple commands that create an empty directory or one with a line of code. The default shell on Mana is the bash shell or the born again shell. And the born part is for, I think it's David Bourne, who wrote the Bourne shell back in 1976. So perhaps the Bourne shell predates some of you, most likely. Let's see. So it'll take a little while to learn parts of the shell as opposed to GUIs where you can just basically click and poke. But as long as you're not doing things like RM for remove, you're probably okay. Doing a little bit of poking around. If you type something wrong, for most things in the shell, you're going to get an error, and we'll go through that. So basically, when the shell's open, you see a prompt. Everybody's used to this. You probably know what ls is. So let's see. In the data set that we have here, we have a typical problem. Nell Nemo is a marine biologist, has just returned from a 6-month survey of the North Pacific Gyre and has been sampling marine life in the Great Pacific Garbage Patch. And she has 1,520 samples. She wants to run through an assay that she has run through an assay machine to measure the relative abundance of 300 proteins, and she needs to run these 1,520 files through a program called goo stats, since she got all this goo out of the Pacific Garbage Patch. On top of this huge task, she has to write up the results by the end of the month. And so to do this kind of thing in a GUI could be problematic. And since you can see that the goo stats is a shell script, the .sh means it's likely a shell script, that she doesn't really have a GUI that could iterate over a bunch of files. And so with the shell, she can navigate to file directory, create a file directory, and she'll be able to chain together commands, retrieve a set of files, and iterate over the files, and run the shell script that contains her pipeline. So I guess we'll move on. The next one, navigating files and directories. So how can I move around on my computer? So how do I move from directory to directory? How can I see what files I have? How can I specify the location of a file or a directory on my computer. Obviously, at this point, most people are familiar with GUIs and file managers, and you just click around, whereas obviously in the shell, you're going to type commands. And I have to, I lost my light here. Explain, so the objectives are to be able to explain the similarities and differences between a file and a directory, translate an absolute path into a relative path and vice versa, construct absolute and relative paths that identify specific files and directories, and demonstrate the use of tab completion. So you may have noticed when I was unzipping my file, I'm a slow typer, so I just use tab to complete the name of my file. The part of the operating system responsible for managing files and directories is called the file system. Today, well, on Mana, there are a number of different file systems, and they're all network file systems. So regardless of what node you're on, whether it's a login node, data transfer node, or a compute node as we are today, you should see the same sets of file systems available to you. Several commands are frequently used to create, inspect, rename, and delete files and directories. So let's go ahead and start typing some. So you could do a pwd, and you should see your home directory. And then, let's see, home directory path. If you're not, I assume most of you are used to the Linux file systems in some measure. They have forward slashes instead of backslashes like on Windows. But basically, just like you would see in a file manager, in a graphic file manager, you have this kind of tree structure. And in Linux systems, everything starts at slash. And the different disks that you would have, like on Mana, would simply be mounted on different directories. So at the top, the root directory holds everything else. And so this is the leading slash in user/nel. So user/nel or home, your username is an absolute path, basically. And then later on, I think we'll see some relative or slack. Okay. Thanks, Sean. Okay, so I got timed out, but I'll just get a new shell. Okay, can everyone see this? So in my home directory, there's a bunch of stuff, but I'll cd into data shell to change directories there and see what's in there. So I can see get my slides and put them out here. Okay, so I have just changed directories into data shell. So if I do a pwd now, I see home Merrill data shell. So why don't you go ahead and follow me into your data shell. So ls has, and most of the commands that exist in, most commands have flags or parameters that you can give them. So you can do, as is suggested in the next line here, you can do a ls-f, and you can see that besides that, the terminal has already colored things so that you already know that these blue things are directories, and the ones that are in black are files. But if you didn't have colorization on in your terminal, you might not know which of these entries were files and which were directories. So you can use the capital -F flag. Okay. And then it goes on to talk about basically the general syntax of commands in the shell are you can have this either single minus and then a single character, or you can have sometimes minus and the longer form. That. Next, it mentions that if you want help on a command like ls, you can go ahead and type ls help, and it'll show you this. And even though it's the command line, you can use your mouse to scroll up to see everything here. And so it has all of the all of different options here. And many of them, as you can see, have both a long form and a short form of the commands. So they're equivalent, but it's just whether or not you want more typing or less typing. Okay, so we saw all of the flags. So if you go ahead and type ls-j, because I think that that's a valid option, you should see invalid option. So if you just, again, if you're just either mistyping or, forget the actual name or designation of a particular flag, if you type it, you're just going to get an error. Usually errors are not deadly unless you're doing RM something, so which means remove or delete. So when you do that, you probably want to think for a minute before you hit return, because especially on the cluster, most things are not backed up, so you should delete things with some caution. So let's see if we can get this back here. Okay, so there's a exercise here to explore more ls commands, but I think in the interest of time, we'll try and move on to some other stuff. There's an important one, is hidden files. So if I ls-l, let's see. Okay, I don't have any hidden files there. But you can see in the long form of format, there's you get a lot more information. You can see also explicitly whether it's a directory and who owns it and what group, how big it is, things like that. So I think, let's see, assuming that the Git part is going to be about an hour, I have about 20 minutes left. So we will talk about the absolute versus relative paths. So the absolute path really just means that that the path that you're typing out, so it's all the directories and subdirectories, and then finally, whether it's a file or a directory at the end, starts with slash. And then relative directories involve these kind of references. So dot is the directory you're in. Dot is a directory above you. So if I go ahead and cd into creatures, I see what's in creatures. We have unicorn and I'm not sure what a basilisk. But if I ls dot, I see the same two files that are there. But if I ls dot dot, I would see what's up one directory, reminding you that I'm in home narrow data shell creatures at this point. So if that makes sense. And then I could also dot dot slash. Let's see. I was hoping for completion, but okay. So I did a ls dot dot notes. You can use many things, including just editing in GitHub. There are some control characters that you can use. So I can do Control A to move to the beginning of the line. And if I decided, oh, I really wanted to see the long form of this. So let me my cursor. And so I can go ahead up a directory and see what's there. I could, let's try to go. There we go. So I can actually go up a directory and down a directory and see what's in North Pacific Gyre. And there's yet another directory. So I could go ahead and I'm not typing, I'm hitting tab. As you know, you've already learned, I'm not that fast a typist. And so I can actually see things at other places on the file system. So is that any questions on that? And so built into the workshop here are these solutions. So you ask questions, you can read these things, and if things aren't making sense to you, you can, I guess, on your own, go through more of this, so that we can continue on with some other things. Is everyone good with that? Pretty much? Okay. So we should be able to even have a navigation down here at the bottom. So I'll just quick run through the points. File system is responsible for managing information on the disk. Information is stored in files, which are themselves stored in directories or folders. Directories can also store other directories, and there's basically a tree. You use the CD for change directory, and so you can change your working directory that way. ls path prints a listing of specific file or directory. ls on its own prints what's in the working directory. pwd is print working directory, and slash is where everything is rooted. The tree starts at slash. So relative paths are indicate that. So I guess I didn't give you right above here is actually a relative path. So I'm doing an ls and then a directory name. So these things with a double dot where you're moving around in directories, those are relative. And in essence, well, I guess this is really kind of direct, but so those dot dot means the directory above, and dot means the current directory. So let's see. So how do we create directories? I guess we're in our data shell. I'm not sure where I am here, but I can pwd, and if I want to get back to data shell, I can just cd dot dot will bring me up. Okay, so I'm pwd back in home narrow data shell. If I just type cd, I'm now in my home directory, but I'll cd back to data shell to be in there. And then the next item on the list is to actually go ahead and create directories. So I guess I'm going to start writing a thesis. here. So I'll go ahead and I will make your thesis. You can see I now have a thesis and there's nothing in it. So it's, and it talks a little here about good names for files and directories. In general, Linux, unlike file managers, which don't care too much about spaces in names, Linux does. So if I wanted to create, if I want to create directories with spaces in it, it's a complication. So you need to use quotes to do things like that. So what, as if you're a novice shell user, you probably want to avoid using spaces, because if you're writing scripts and you're moving around, you would then need to account for quoting things. So I can go ahead and let's see, well, it's best to. So spaces can make a name more meaningful, but spaces are used to separate arguments on the command line. So if I have a file that was north space Pacific Gyre and did an ls north Pacific space Pacific Gyre, it wouldn't find any files, because it would be looking for a file named north, a file named Pacific, and a file named Gyre. Okay, so next thing we're going to do, and that is super important when you're on the cluster, is you need to choose an editor. So if you're are a novel user of the Linux shell and are just starting out, the simplest one is Nano. And so here, let's see what we're going to do. We're going to write our draft. So we'll go ahead and say Nano. And if I try and type completion, there is no draft yet. So I'm going to have to type it out. And it could be text, or it could just be draft. In general, Linux does not associate these file extensions. There's no association built in to Linux, unlike on Windows and on Mac, where a specific extension might have some association. You click on it, something happens. In the on Open on Demand in the file manager, there may be some of those associations, but in general, so I'll go ahead, and Nano is not found, and maybe David can tell me why that is.
There are a module on the nodes.
Okay. So I'm going to have to do this command, module AV nano, and I'm going to have to module load. I can just type, I do have to type load correctly. So there is only one Nano module, so not all the software is automatically installed on everything. On the login nodes, if we had done this on the login node, Nano would be there. But on the compute nodes, since they're mainly meant for doing computation, you have to load the module. They're not installed by default. So since there is only one, I should be able to say just module load tools nano. And now when I type, I can up arrow to back. I hit the up arrow key and got back my nano.draft text, and boom, I'm in the Nano editor now, and so I can just start typing stuff. So I can type some stuff in, type some more things, and basically down at the bottom of the screen in Nano, it has all of the ways that you can maneuver around. You can write out what's in the file in case you're worried about getting disconnected. You might, if you're writing some really long thing, you might want to occasionally hit Control W. Let's see. So go back. Cancel out of that. So if I exit, it'll ask me, do I want to save the modified buffer? And I'll say yes. And I want to save it to draft.txt, or I could change it V1. And yes, I want to save it under that name. And then if I do an ls, I can see that I have a draft v1.txt and not the file name that I initially entered. There are a couple of other editors on Mana. So there's Emacs and VI. And I guess on Open On Demand, there's also more complicated things like VS Code to an integrated development environment. But basically, if you're getting started, Nano may be what you want to start using. I have known people that edit on their local machine and then push stuff up. And maybe if you're using Git, as Ms. Eddy is going to talk about in a short time, you might operate easily in that mode. But if you're just using the shell and not using Git and doing stuff on and editing directly on Mana, you may want to use Nano. So there is a command called touch that can create files. So I could just say touch file. You can see that now I've created a file here at the beginning. So it has some other properties, which I guess basically changes timestamps as well. Another important thing is moving files. Sometimes you want to move files from one place to another. If you're moving large directories around, I really recommend copying instead of moving, because you also, one thing that's not true on a individual machine, you may have just one disk in it. And so if you're moving, it's a relatively simple operation, but on the cluster, if you're moving between file systems, then what move is doing is not just like changing pointers, it's doing something more where it's actually doing a copy and then a delete. And for the most part, there's a lot of redundancy built in, and that works well. But if your files are really precious to you, I recommend copying, doing something we won't go into here, but some kind of checksum to make sure the two things are the same, and then go ahead and delete the originals if that's what you want to do. So basically, the syntax here is you can do a move from some other directory in here, and kind of just jumping around here. Slack. Not sure what that's about. Okay, so let's see. Some moves and some copies. So I could do something like CP a file to, I'll put it in thesis. So CP assumes that it's a copy. So now I can ls thesis and see that I now have a copy of a file. I guess when I opened Nano, I had not actually CD'd into thesis, so I should probably move my draft in there as well. So I'm going to draft thesis, and you can see I have 2 files in there now. Some other items here. So that's a little bit about copying. There's copy -R if I want to copy everything in a directory to a new directory. So back here, I can do CP -R, thesis. I can ls thesis. And I'll throw in a star, which means find everything in the directory that I'm in that begins with thesis, and you'll see that I have thesis with 2 files in it, and I have thesis backup with 2 files in it. So does that make sense? You know, we're kind of going a little quick here. And then here's the important and dangerous commands is removing files and directories. So you want to make sure you know where you are. So pwd, and I'm in data shell, and I'm going to go into my thesis and decide that what I wrote is not really that great, and I'm just going to remove my draft. Okay. So now if I ls, it's gone. But what if I decided I wanted to remove a file and the whole thesis directory? I could cd back up and say rm thesis. I want to get rid of everything, and it tells me I can't do that because it's a directory. So rm by default will not remove things. If I do rm, I hope this works. This one is help. I can see, oh, I want to recursively delete stuff. So if you want to remove a directory and all the contents below it, you can do rm -R. But before you do that, make sure you know which one you're doing, because or which directory you're removing, and that you really want to do it. So you would want to pwd, make sure where you are, do ls, and okay, I really want to do it, so I'm going to go ahead and rm -R thesis, and it doesn't complain anymore. When I do an ls, it's gone. And so, but if I have regrets, I can go back and restore my thesis backup. Let's see. So that's a quick slog through this. You can see that the actual just this section alone really should be 30 minutes of teaching and 20 minutes of exercise. But in order to have time to do Git, I'll take us back to the start of things and just make note that all the way up through finding things, that these are all aspects of the real software carpentry shell novice. And so it's up there. This is up here in this GitHub workshop. These are ones that I didn't cover, but I left myself, and I'll go into Massetti's time for 2 minutes because I really like find. And so there's a command called find, and there's a command called grep, and find can, you can really explore around in a file system once you know find, but it's complicated. So at this point, I'll take any questions you have and then pass it over.
It seems there's no questions, Ron. I'm not sure.
Looks like no questions, so it's,
Yeah,
it's all yours.
I wanted to wait a bit and be sure before I just jumped in.
I'll stop sharing at this point.
Okay.
You're going to share, or is it?
Yeah.
Yeah, you should share.
I think I'm gonna.
Stop sharing. There you go. So thanks for your patience.
All right. Sorry. So we're gonna be staying on the same link that Ron shared earlier, but then we're gonna start at. Hold on, let me just share my screen. I'm there. I'm not sure how to do this. Sorry, sir. Let me just. Okay, there it is. I'm not able to see anyone. Oh, there you are. Okay. So I'm going to be covering the portion on Git and GitHub. But I'm not going to go into a lot of depth as to like some of the very advanced stuff. I try to stick to things I know that I use and I think would be useful to other students who would actually start using Git, because I've met a lot of students in like the other departments, like the biology department and so on, who don't really use any type of version control or anything like that. And then the minute I showed them some Git, and they felt was really good. So first of all, GitHub is a version control, is used for version control. And not just that, but it's also really good for collaboration. So not just for keeping your own work, but also it allows the ability for you to work with other people. So the stuff that we'll be covering in this first section is to understand the benefits of using automated version control systems, to understand the basics of how they work and how to configure Git so that it actually works for you in the best way. So Git, or most of the automated version control systems, have pretty much existed for a long time, but only now are we seeing, but then back in the days, like maybe in the 80s or so, they were used mostly by larger corporations, but it wasn't the version that we know now that is more like a lot of like front end and all that. So the popularity came mostly because I'd say that and this is not a fact, I am just assuming, the popularity with people came because of the introduction of things like GitHub and GitLab that allowed people who are not necessarily programmers per se to use these interfaces that you don't necessarily have to understand the commands so much, or so you could just click and have it working. So the first thing, if you're working on a computer and you want to like get yourself set up for Git to use GitHub. So for example, if you're logged into Mana and you're and you're in the terminal, you'd first start off by configuring your environment, and that would mean like you use the git config command together with global, and global pretty much just tells Git to use this username and email for any repository that you have afterwards. So not just the current one that you're working on, but in perpetuity, just use this username and email. So if you type this in your command line, you'd be able to set up these two. And there's another config setting is the line endings. So different different systems see the tab or returns key as a different thing, and it could record that in, like, it could see that as a change in Git or not in some cases. So the recommended setting would be this one. If you type this command, then you would have the setting for Linux, and then for Mac and Linux, and then for Windows, you'd use the one below. And the other thing that you need to be able to use Git is a text editor. So some people pretty much use I don't know what people mostly use, but I use a combination of a few text editors. For example, I use Sublime Text because it opens quickly. I like it because of that, but I don't use it extensively for all my other projects. And then I also use VS Code because it really gives me a large overview of my whole project, especially if you're using GitHub. It shows you all the directories. You're able to move between directories really easily and see how everything is looking. So I use the combination of that and Sublime Text, and Sublime simply because it opens quickly. Say I want to open something else on the other side, I can quickly open that and copy some code and paste it. So those are the two, but you could literally go with any that you prefer. And then there's a few other things that you could do in the config, like help, to say which kind of command. Then the help command helps you to understand what other commands do in Git. I think it's almost like you would compare it to the man command in the normal terminal. I think it's pretty much like it works in a similar way to that. So eventually, so at this point, we know that git config is used to configure your GitHub and like your environment. And then the global setting is used if you want to have those settings stick for like perpetuity, as long as you're working in GitHub and on that computer, using that username and email address. Hold on. So. Okay, so I'm gonna skip this section and go to the next section. I'll come back to this. I figured it out later that it makes more sense to start visually, because at this point I feel like I've just been speaking, and I don't like it when I don't see what I'm speaking about sometimes. So I'm not sure do I have to go through this and do it with you as you do it, or do I have to go through, because I'm not too sure how I have to do that. Because I could open that, but then I'm going to be looking the other way the whole time. So I don't want to do that also. So I'll just walk through it without actually doing it, because I've already kind of done it. So GitHub would look like this. I'll first open GitHub. I think most people are familiar with GitHub, but I will open it anyway just to. GitHub looks kind of like this, and you have your whole thing and all your repos down there, and it would list them and all the activities. I think someone has gone through this before, but I'll just go over it kind of very quickly. It shows the activity, like when you've been working on, like, and so on in the years and stuff like that. And then it also shows a history of current, like recent activity that you've been doing. And then the other important things are, so that's where you have your repos. Projects are, I think projects are similar, are related to repos. If I think, I don't remember exactly, but I think they are related to repos. I could be thinking of something different. So that's what you have. And then on your profile, you have your profile repos, code spaces, organizations like the one we are currently on, which is this organization here, the CI tracks. And you'd have different organizations depending on what you're working on. For example, I have one with our AI lab with Peter and them there. So you change as you click each of them, then the different repos from each of them would load, and you'd be able to work on them. So now that I've gone through that, I could do this and have you go through this like this, but I think it makes more sense to do it. I'm not sure if it makes more sense to do it live or to follow this, but I'm not sure. Does anyone have a suggestion? I think I could do more if I do it live. Like I could show more stuff. But anyway, yeah, I'm gonna repeat exactly kind of the same thing I did for this. So what you wanna do in the first case, let's say you start working on a project and you want to host it on GitHub. First thing you do, you create the repo, and that would be right there in your profile. So you'd create the repo and name it, and you kind of want to have a descriptive name for that, so that you remember exactly what it is. Especially the minute you have a lot of repos, then you kind of lose track of which is which. Also, it's kind of hard to find names that are meaningful. That's the other thing that I picked up. Like, so by now there's so many repos on GitHub that it's becoming really hard to find names. You have to add some special characters or something like that, or a combination of caps and lowercase and special characters to get the one that is very meaningful to the project that you're currently working on. So for example, in this case, I just went with SSB test, so software, scientific software basics test repo. That's what I went with. And I had to put the underscore to get the name. And you want to include a description to your repo to say what the repo is about. And this is very helpful because in some cases, people go on GitHub and like people search for some stuff they want to solve, a small problem that they don't really want to write code from scratch about. And it helps a lot if your repo has a description, because people can read your description up front before having to look at and like clone your code and everything. So they can kind of see if it works for them or not. And then you can choose to have it either public or private. And then you can add in, it's always advisable to add a README file that explains even further what your code is about, or your whole repo is about. You can add a .ignore file. And this you use, for example, in cases where you have data, you have both code and data in your repo. Sometimes you'd have data that is like large files. For example, if you're training machine learning models, most of the output models are really large files that you'd find it's like a few gigabytes. And you don't always want to push that with your code every time you push. So you just include that the extension of that file in the .ignore file to say that every time I push, ignore this file, don't push this, because it's a huge file, maybe 55 gig. You don't want to be pushing that. And I think GitHub does have also does have a restriction as to how much, like how the size of files you can push onto GitHub. So it's really important to have that. Also, sometimes the other reason is you have data that you can't really share, but you want to share the code. So data could be from an organization that hasn't allowed you to share the data or something like that. So you include that in the .ignore file. So once you do all that and you create your repo, then you'd have something like this. But then it looks different right now. It should, like, because I already created a README file, I already have something to look at under code. So I have that. But if you hadn't, it would have looked like this, because you wouldn't have anything that's code. It would have kind of looked like this under this section here. But because I created a README, then I already have code, like under code, I have that. And then, so this is all sitting in a remote server somewhere. And to be able to work on your local machine and then push these changes, or on the cluster and push these changes onto GitHub, you'd have to clone the repo or kind of make it local in a way, have a local version of it. and that you can get that like on the code part. You click the green button, and then it will show you these options. You could either, sorry, I'll just switch off my phone. You could either use HTTPS or SSH. Normally, I think most people that use a cluster use SSH, although I haven't done that myself because I always find it troublesome because it needs you to have some keys and all that stuff. That's like, it's more secure, but normally for the kind of work I'm doing, I don't really care much about like how secure it is in that case. So I always use the HTTPS. So at this point, you might want to go through this. In your batch, make a directory and go into it. And then if you go into that directory and then say git init initialize, you'd find that the directory would be empty and it wouldn't be a git directory. And by saying that, it might, I think it does, sorry. I swear I don't know how to switch off my phone. Yeah, thank you, sorry. So there's two, yeah, if you go through this, you'll eventually have like an empty directory that you wanna have your, that you're gonna have your repo sit inside. Normally, I'd like to do it like that, or you could just go to your terminal and pull and clone the repo directly, but then it might not sit in the location that you want it to sit at. So I normally make sure that I go inside some other directory and then store it in there. So that's how you would go about copying like cloning your repo onto your local machine. So you, like I showed you, you copy either the SSH portion of it or the HTTPS, one of those two transfer ways, protocols. You'd use one of those. If you use SSH, then you'd say git remote add origin, and then this portion here that you would copy from the SSH. That would be the SSH path that you copy, and that would that would link your local the local repo to the repo on GitHub. Or you could use HTTPS by saying git clone and then run that, and you get an output. The output looks bad, but it shouldn't look like that. But it just basically says it's cloning that remote, and it tells you that it's done eventually, and it says unpacking objects, 6 objects or something like that. And then to see if that worked, especially for the clone, if you use git clone, then it shows you this. But then if you use git remote add origin, it would just do that, but it wouldn't say anything. And to test if it worked or not, then you'd say git remote -v, and then it would kind of show you that, okay, origin, and then it would show you all that, fetch, push. Those are the things that you'd be able to do from your local repo to the remote one. And eventually, if you make changes to the files once you have them, then you can push, and it pushes to the main branch instead of all the other branches, because you could have different branches in GitHub based on where the point you are at in the work that you're doing. And with that, I'll just show this slightly, really quickly. I mean, sorry. Okay. So for example, I'll just pick one that I've been working with Ron and show that instead. So for example, in this case, the work we've been doing with Ron, if you see here, this is kind of our main branch that we've been working on. And then these other branches is kind of the default branch is this one, but then you have something called the main, and then this would be the one I was working on. So that's just is what the branches are. They're just like a version, a separate version of the code that might have more changes or could be the same. And every time you can compare branches every time and see whether they're the same or not. And like if you make changes in one branch, then you have to make a pull request to say, okay, I want to merge all the changes I made into the main branch or something like that. So if you push to the main branch, then that's what it would show you. And it kind of does say that it was a success or not. And then you know it has done what it has to do. The other thing, but I haven't done this also, is that some networks have proxies, and you kind of have to set up set up the configurations in a global way so that they stick for any other project that you work on. And you'd specify the proxy that GitHub should use when you make your pushes and your pulls from the remote repo. And the other thing is password managers, although that too I haven't used, but I kind of understand how it works. And this works if you actually use an SSH key. You would use a password manager to kind of store your stuff and store your details about your password and your username. And every time Git pushes, it would try to pull that information based on where you set them or you unset them or something like that. And it would use that information to make sure that you push or pull securely from GitHub. So this portion I'm gonna skip. You could go and see afterwards if you wanna. I just wanna make sure that I cover all the other stuff that I just skipped. So, yeah. So I've shown you what GitHub looks like in your browser and how you get it set up in your on your local machine. And once you have that, I'm not sure how many people actually use GitHub on the cluster. I'm not too sure how people use it in that manner. But so, for example, the way I use it is that I only try to use the cluster for computation. I don't actually use it if I don't need computation, because I like to be in my own environment and use my own machine most of the time. So meaning in this sense, I have my GitHub linked to my local machine and to like a repo on the cluster. So even when I'm on the cluster, I can still make changes and push to GitHub. Even if I'm not on the cluster, I can still write code on my local machine and push changes, and that they'll still reflect. Eventually, when I go onto the cluster, I pull and I'd still see the changes. So it's tracking changes and what has happened is really important in that sense. Most of this part I'm gonna skip because Ron has kind of covered most of the stuff in his portion of the terminal. It's all about how you see where files are in directories and how you open files, how you see what's inside files. And Git status is pretty much, it looks into a Git repo or a local Git repo. And if you say Git status, it kind of tells you whether there's been changes in the repo or not, and what kind of changes have been there. So for example, untracked files would be files you have changed on your repo, but haven't really pushed or committed to the remote version of your code. So to do that, let's say you make a change on your local machine and you want to actually have that stored somewhere, then you'd say git add. So it kind of stages this commit it just stages it, and then eventually when you commit it, it changes, it makes the change to only the local version of your code. And then when you push, it eventually changes the remote version of the repo. And the other important thing is when you make your commits, it's important to include comments to say what kind of commit this is, or what did you change. And the key to that is try not to, like, those comments should be descriptive, but at the same time not redundant. So you don't want to, if you make a change like this, for example, if you make a change, you don't want to repeat exactly everything. You don't want to say, oh, I added a line that says people need to buy more, I don't know, anything. You don't have to write that whole thing. You just have to say what kind of comment change you made. But at the same time, you can't just write a message that is very short and non-descriptive, because then you lose yourself also, because at some point, if you find out that there's a problem in the code and you want to find out exactly where it came from, then you might not be able to track that, because you've lost yourself also, because your messages are not descriptive enough, right? So there's a few other comments like the git status that I've mentioned before, and then there's a git log. And the git log pretty much gives you like the commit, because each commit has a sort of ID, and it does say who made the commit and on what date the commit was made. And then it could also give you the message of the comment of the commit to say what kind of message was stored in there. So Nano, I think Ron has kind of covered these parts. This would basically be making a file, and this would be printing the outputs, the contents of a file to see what it looks like and all that. So most of these are not really anything new. And git diff would show you the difference between the current and the previous version of the repo, to see what kind of changes happened. Like, for example, how many lines you would have added lines of code or removed a certain number of lines of code. And eventually it shows you the commit. And that's to this part. I'm gonna go back and show you how this would look like in the, if you do it this side or in the GUI. So in the GUI, for example, you go and let's say I make a change to something. Let's say I have a file. I'm just going to change any one of these files. So just maybe make a change. I don't know. I don't even know what I would change. So, okay. Okay, I'm just gonna make a change at the top. I'm just gonna say, so once you make a change, then you'd write like kind of, normally these are linked to things called issues, but then currently we don't have issues. So normally you'd link your kind of commits to issues to kind of say what this commit. So normally you would have issues. This would be things like, if we're working on a project together, someone says, like, creates an issue by saying, oh, we need to work on this thing. And that issue would be numbered. And eventually when I make commits, I'll try to link that to some numbered issue, to say issue number 6 or something like that, and it would have a name. And then I'd say exactly what I did that relates to that issue. Maybe, so in this case, I did make a random comment, so that's what I would say. And then you push it like that. So this is pretty much similar to what you do in in the terminal, but in the terminal, you actually have to put a message yourself that would show that. So there it would show that I made this commit, and exactly the same as how you saw it in the GUI. It has some sort of ID, and it says when this was done, and there would be there the comment is. This portion just speaks of like the staging area, just to explain what each part does. And I think I've already covered this to say what commit does versus what push does. So commit is just for your local version of the code. So on the cluster, it would just be on that. And then when you push, that actually pushes these changes to I think it's I'd say, yeah, to GitHub. But that's pretty much it for this portion. I don't think most of the stuff that's remaining is not so, it's not very useful, mostly in the day-to-day of what people do. So I'm not gonna cover it, but then you can always go back to it if you wanna see what it looks like or what it is. I'm gonna now go to the last part. Sorry, so the last part that I have is just an example. It's just an example of what a README file would look like a good README file would look like. Because with your repo, you want to have your repo and a descriptive title to it and a good description of what the code is. And then it also helps, especially if you have a lot of code and like a lot of files that interlink and like different folders and directories, it helps to have a good README file so that people can kind of read that and it helps them follow your code much better. So for that, I'm just gonna go and show an example of that. I think I showed this last time, but I didn't really go much into detail as to why it looks how it does or why I did that. So I'm gonna, for this portion, I'm just gonna go, I think I can share that. So does the chat, can I still send a chat message? Okay, there. So that's where it is. I'm just gonna go through the different directories and try kind of give an example of how, what each, like how I would say each of them is and why it's good or bad. I think that would be kind of be, so for example, this repo here was a class project that we worked on, and you can kind of tell it's already useless to someone who doesn't know what it's about or someone trying to find some code, because first of all, the title is not descriptive in any way. It just says 645 scripts, and there's no description at all as to what is happening in the repo. So meaning this is pretty much only useful to me and the people I'm working with. But otherwise, to anyone else, it's completely useless. There's absolutely nothing there. There's no, the README contains nothing. So it's a really bad, this is an example of a really bad repo if you wanna have one like that. This is how it would look like. No description. The title looks bad and pretty much it has no README file. The second one would be one that looks like that. So for example, the title is kind of descriptive, as much as it's hard to find descriptive titles now. So it's genetic ML. So you can kind of guess that if you're someone who works in either genetic algorithms or machine learning, you kind of guess that it's some sort of combination of genetic algorithms and machine learning. And then it does describe that this library uses genetic algorithms for automated hyperparameter optimization, machine learning, and all that. So it's a really descriptive title. And the name also is, the title and the description are really good. And when you go inside it, it does have a README file, although, and actually the README file is pretty useful because it says what it's about. It says exactly what kind of models are supported. So meaning you can only use this library with these models. And then it says exactly how to download, how to actually import or install this from PIP. And then it shows you step by step exactly how you go that. Like after installation, this is what you do in your Python. This is how you load your data. And it uses a common data set instead of using if you use like a very specific data set, people will not have access to that. So making examples using data that is only accessible to you is kind of not good, because then someone else can never replicate the work that you did here. But if you use a data set that that is publicly available and everyone has access to, then if someone goes through this, they can totally replicate what you did and get the results that you say they get. So that's exactly how you go about that and run that. And it shows how to run each algorithm separately and how to get results. So this is kind of a good README file. Not the best, but really good, because for one, it shows you how to use the library, but it doesn't really tell you much about how the library was constructed or what kind of parameters it takes or what ranges. But it's still kind of a good one for someone who just wants to use the library and not really try to change it or understand it much. The third one I'll go through is this, but I'm going to go through this one faster. So like the first one, it has a good description and all that. The code is not really organized in the best way. And I say this because based on what I've seen other people do when they work on their projects and make them public on GitHub, they really try to organize their code in a very standard way, and you can kind of really follow most things. But I guess I kind of made a good attempt at that, because this would be the source that says a lot about where the source is and the images that are related to this data. In this case, I did release these images because it's not many images, and I don't really mind the fact like the data set was my own, and I could just release it. And this way, someone can actually replicate all this work that I did in here and get the results exactly as I got the results. And it's pretty descriptive. The README file is pretty descriptive. It does say what Python version I'm using and what PyTorch version, and it's pretty descriptive. And what I tried to do here, because this was a really hard project and I struggled myself with it, so I kind of tried to document it as I went the whole time and say exactly for each part what I did. So the whole thing was just trying to make a camera for my room that would recognize when someone walks into the door or closes the door, opens the door. And it really goes through everything from how I annotated the data set, and it shows each portion. So it splits the code and says this portion only works with this, and that's what it does. And so it's really good. So if you go through this, by the time you actually try to replicate the results, it would be very easy to get that to work. Or if you get stuck, because you can always go back and look at that specific region, like registering a data set and all that. So it says everything exactly how it was done, how everything was done, sorry. And eventually I showed results to say, oh, this is what it would look like. And eventually you have a video prediction that runs, and I'm not sure if that would actually work. So I'm just gonna open it anyway. And eventually I share the results of that. I share those predictions to show exactly what kind of output you'd expect. So for example, it shows me, it's predicting a person and then a door and an opening. So the whole goal is to see a person and then a door opening or closing. So that's pretty much it. And you could use this for anything, your own kind of work or anything close to that. As long as you follow this and register your own data set that's different, then you should be able to get kind of the same results. Okay, I'm gonna go through just one more, and that would be it. This would be one I think is interesting. The description is kind of good also, and the title is kind of descriptive in a way, because it's related to BERT models, which are machine learning models. And it's kind of good. It's kind of okay. Machine learning models, and these are based on transformers and therefore language. I did this as an attempt to kind of have a working language model for one of the languages in Africa, because I scraped Wikipedia for that language and then tried to create that data set. And I did this as an attempt to learn, but at the same time show other people how you would do that. So I go through what I did and how you would use the model and what the kind of outputs would be. And then I explain what the data is. And this is slightly different because this model is hosted on a certain website, and I kind of have to explain things like what the training data is, because it's not just for fun. Other people could use it for other things. So I have to explain these things like what the data set is, the size, where I sourced each portion of the data that I have to eventually have this whole thing. And then the training procedure, and eventually I say how I train the model and how the training configurations could be found there. And then eventually, well, I don't have anything to cite, but that was pretty much it. So yes, I think I've pretty much covered most things I'm interested in covering in GitHub, or I think people could use or find useful. If anyone has like a question or something they want me to talk about further, I'd be more than happy to show how that is done, or how anything, if there's questions. I guess not.
All right, thanks, Mazzetti and
Right.
Ron. Those were great. Thank you so much. Hopefully everybody could follow along and learned a bunch today. Thanks for putting these together. Looks like we're pretty much right on time too. Nice job. All
Thank you.
right,
Thanks.
clap for everybody.
Thank you.
Good. How's everyone else feeling about running their workshop? These guys just finished theirs, so we're looking forward to all of yours. And yeah, and so Maria has posted a workshop survey in the chat. So if you guys have a chance to fill that out, mostly what we're doing is trying to collect a little bit of feedback so we can improve the workshops as we go along. So great. So if you take a minute to just fill that out, that would be really helpful. And then don't forget, this weekend is Halloween. So I hope you have all your costumes or whatever you're going to do for fun. Stay safe, wear your mask for Halloween. Okay, folks, anything else before we take off for today? Ron, any parting comments, or Mazzetti, anything you'd like to tell the class before we go?
Well, I'd just like to thank Mazzetti for working with me. It was nice working with you, and good job on your part of it. So thanks.
No, thanks, Ron. It was fun. I actually learned a lot about Ron the whole time. Like, we've just been talking, and he gave me a lot of advice about stuff, and like, yeah, it was really good. Yeah.
Don't follow any.
No, I wasn't gonna, but it was still great to hear it.
That's really great to hear, because that's actually one of our kind of stealth tactics here. We pair you with somebody else and hope you guys learn from each other. So it sounds like that was a big success.
Yeah, it was.
Awesome.
It was.
We were at opposite ends of using Git. I had used Git in the distant past to do configuration, more than 10 years ago, but certainly didn't know much about GitHub. So
Yeah, awesome.
now I know.
All right, one down and plenty to go. Have a wonderful weekend, everybody, and we'll see you back here next Friday. All right, see you soon.